So in the previous video, we talked about how we can use the subscripts of a balanced chemical formula to relate moles of the entire compound to moles of part of that compound. Now we're going to take that concept along with molar mass to do some element composition problems. So in both of these problems, I have 1 gram of Na3PO4, sodium phosphate. And for this first problem, I want to calculate how many grams of sodium, grams of Na, are in 1 gram of sodium phosphate. So I have this little flow chart up here to kind of center yourself as to see what you're given and where you're going. We have grams of some substance, sodium phosphate. I need to get to grams of part of it, specifically grams of sodium. First step is to use the molar mass of sodium phosphate to go to moles. So I use the molar mass of sodium phosphate. There we go. So this 163.94, that's the molar mass of this. So 3 sodiums plus 1 phosphorus plus 4 oxygens. Wrote that molar mass so that the grams is in the denominator, moles is in the numerator. So I'm gone from grams of substance to moles of substance. I now go from moles of substance, sodium phosphate, to moles of sodium by using chemical formula subscripts. So for every 1 mole of that molecule, I've got 3 moles of sodium from the subscripts in the formula, written appropriately so my mole units cancel. Those cancel there too. Now I'm left with moles of sodium. I'm almost home. I'm at moles of sodium. Now I get to grams of sodium by using the molar mass of sodium. Remembering that molar mass is always in terms of 1 mole. And I had to write that down here because I ran out of room, but it is multiplied. So the 1 mole Na, sodium cancels with that mole of Na. I'm left with grams of sodium, which is great because that's what I'm looking for. So in your calculator, 1 divide by 163.94, multiply by 3, multiply by 22.99, and to 3 significant figures, which is what I was given in the problem. You can think about these molar masses and conversion factors as exact numbers. To 3 significant figures, my answer is 0.421 grams of sodium. We're going to do a similar song and dance with the 1 gram of sodium phosphate, but now look for grams of oxygen. So I'm still going to use the molar mass of a sodium phosphate to go from grams to moles of sodium phosphate. But now since I'm looking for oxygen, I need to use a different ratio. For every 1 mole of that sodium phosphate, I have 4 moles of oxygen. Again written appropriately so that your units cancel. This should say oxygen. My apologies. Last but not least is the molar mass for oxygen. That I did get right. For 1 mole of oxygen is 16 grams. I put that down here because I ran out of room. My mole oxygen units cancel. So in your calculator, 1 divide by 163.94. Multiply by 4, multiply by 16, and to 3 significant figures, that answer is 0.390. So you should feel comfortable being able to do problems where if I give you the mass of a compound, you can find the mass of part of that compound or part of the element that makes up that compound by doing this 2-step or 3-step dance, going from grams of compound to moles of compound, using that compound's molar mass, using the subscripts of the balanced chemical formula to go from moles of compound to moles of the element you're looking for, and then finally moles of element to grams of element using that substance's molar mass.